Did you find a definition for evaluate? What do you think evaluate means? Go ahead, Monte.
So find the value of an expression.
Yeah, find the value of an expression. If they tell you to evaluate, they want you to find the value of an expression. Now, if it's a numerical expression, you should be able to just go to work simplifying it, doing the computation, because there won't be any variables involved in it. But if it's an algebraic expression, we know algebraic expressions have variables in them, so we're going to have to put something in for the variable, and then we'll be able to evaluate it. We'll be able to do the math computation, okay? And we were actually, that's what you just did when you were doing the day 2 problem for today. You were evaluating an algebraic expression. They told you what they wanted x to be, you substituted it in, and you found the value for that expression when x was -4. So that's what we're going to be doing here. So let's go to page, or we're on page 7, hopefully we're still there. Look at example 3. What's the next objective in our lesson? Go on. Yeah, evaluating algebraic expressions. Will you fill that in, please? I'm doing a very good job of writing here, so I'll go back. Evaluating, and it's in blueprint right beside your example 3 in your book if you can't see up here well. It's easier to copy from the book. And you do need to be doing this. So, example 3 is going to be for you to study on your own. We're going to go to the check it out problems that it says right there at the bottom of page 7. And our directions tell us we are to evaluate each expression for m equals 3. Let's write that down here in our notes. M is going to equal 3. It says they want n to be 2, and they want p to be 9. So in all of our algebraic expressions that we're going to evaluate, that's what they want us to use for m, n, and p, whenever they show up. Okay, so 3a. First thing I always want you to do here is I'm setting the standard for how you would show work for this. First thing I want you to do is write down the algebraic expression that is given to you. Our algebraic expression for 3a, our first problem, is mn. What does that mean, mn? Cody?
3 times 2.
3, no. What does mn mean? Listen to my question. What does mn mean?
M times n.
There you go. M times n. So when we substitute in, we're gonna make sure we understand that we need to do the operation of multiplication. So now we're gonna do what you wanted to do there, Cody, and that is put the 3 in for the m and the 2 in for the n, and you'll show that substitution step it's called. So you'll write the algebraic expression first, you'll show the substitution, and then you'll do the computation. 3 times 2 is 6. Okay, and we don't use our calculator unless we absolutely have to. Don't let your brain be a machine. We can multiply 3 times 2. We just evaluated mn, given what they wanted m to be and what they wanted n to be. Okay, questions on that one? Okay, let's write down our next algebraic expression. P minus n. P minus n. Or P decreased by n. Or n less than P. What's the next step? When we've written down the algebraic expression, what do we do next? What's that step called, Jessie? Are you what?
I don't know what it's called, but
We just put the numbers in, don't we? Yeah. Substitute. We substitute. We do the substitution step. So we're going to put 9 in for P. We're going to put 2 in for N. And we're going to show what we put in for them. And then we're going to say, okay, I can do this with my calculator. 9 minus 2 is 7. 9 minus 2 is 7. Okay, you do the last one on your own. See what happens. Show all the steps. You know what the standard is now. Okay, our algebraic expression is P divided by N, or the quotient of, oh, it's M, not N. Put a little hump on, another hump on there. P divided by M, and P is what? 9. M is 3. Can we do that without a calculator? Absolutely. 9 divided by 3 is 3. Okay, we have evaluated the quotient of P and M given that we know P was supposed to be 9 and M was supposed to be 3. Okay. Notice there's not an equal sign anywhere, is there? We're evaluating expressions. We don't see equal signs when we're evaluating expressions. Okay, we have one more objective in this lesson. Turn in your books to page 8, flip the page. Example 4. Typically the last objective, the last example, they don't necessarily have a blue title for it, but we're going to put application, because that's typically what they have us doing. Can we now take what we've learned throughout this lesson and apply it to a word problem? So, what's your title? This is the objective. Can you do an application? Okay, and then we're going to do, I want you to put this in your notes, we're going to do the check it out. Page 8, and there's only one check it out on that page, so we don't even have to identify where it is. We're going to do, so again, I'll give example 4 for you to study, and we're going to do the check it out. So we're doing check it out problem number 4, and it has a part A and a part B, so we'll start with part 4A. Okay, read that sentence to yourself, what the check it out problem is about. Hey, can somebody tell me what kind of information did they give us? They're going to make sweaters. Yeah. And what are they going to make these sweaters from?
Bottles.
Plastic bottles. So they're going to recycle plastic bottles. Do they give us any other information? Do they say how many sweaters?
To make one sweater, 63 ounces.
Make one of them and take 63 bottles, right? So it takes 63 20-ounce bottles to make one sweater. So 4A, it says write an expression for the number of bottles needed to make S sweaters. S being how many sweaters you're going to make. So what algebraic expression could we use that would show the total number of sweaters, or the total number of bottles, made according to the number of sweaters?
63 times S sweaters.
It's okay, so 63 times S, and we don't have to put the sweaters in our work here quite yet. I'm going to clean this up a little bit and say this could also be written 63 S, and then we can call them, are they sweaters? Is that the label? Oh, really? If you take 63 times S, which isn't S the number of sweaters, if you take 63 times S, that tells you how many sweaters you're going to have? Well, what's it going to be then? Bottles. It's going to be the number of bottles it's going to take. So we can't call these sweaters. This is bottles. It's going to take that many bottles. Take 63 times however many sweaters you want to make. If you want to make 10 sweaters, then how many bottles is it going to take? 63 times 10. Oh, that's an easy multiplication problem. 63 times 10. What is that?
630.
630. Okay. Now I believe in 4B they are actually going to have us do some evaluating. So we're going to.
Why did you say 63 times 10?
Because I was just using an example. I said, so this we could use this expression to figure out how many bottles it would take to make 10 sweaters. Okay? Because that's what they're going to have us doing in B. Find the number of bottles needed to make 12, 25, and 50 sweaters. Now my calculator might come in kind of handy. We're going to make a table, okay? First of all, we're going to make a table, and we're going to have a column that represents the number of sweaters. And we know we got to do it for 12, we got to do it for 25, and we got to do it for 50. And then we're going to use our expression that we just set up, because that's why we set it up, is so it would help us calculate the number of bottles. And then lastly, in this last column, this will be the total number of bottles that we're going to need. So total number of bottles. So we're gonna, this is our way of showing work this time. So let's room. We can substitute in our middle column. That's what our middle column is going to do for us. We'll substitute in our number of sweaters. We'll get our handy dandy little calculators out and say what's 63 times 12. Or do it in your head if you can. So 756. We don't have to put a title on that because we already have a title in our heading in our column. Okay, now we're going to substitute 63 times 25. This is a multiplication dot there, not a subtraction that almost looked like. 63 times 25 will be our next substitution. How many bottles is it going to take to make 25 sweaters? Noah?
1,575.
Okay, 1,575 of those plastic bottles will be needed for 25 sweaters. And our last substitution step, 63 times 50. Well, 50 is twice 25, so I should just be able to double 1,575, shouldn't I? Okay, I'm going to predict. I think it's about 3,150. Am I right? Okay. 1,500 doubled is 3,000. 75 doubled is 150. 150 plus 3,000 is 3,150. And we are done. Amen. Okay, here's what you need to do now. You need to get our sheet of listening paper. And on that sheet of loose leaf paper, either in the upper right or in the upper left, doesn't matter which you pick of your paper, with your pencil, don't make it all the way across the top, you're going to make a heading. So whether you like the right or you like the left, you get to pick, but put your name first. First line of your heading is always your name. Whose paper is this? And the rest of the heading is right here. Number 2 goes on the next line under that. There's really no lines in there in that white space, imaginary line. The next line of your heading is number 2. The next line of your heading is page 9. The last line of your heading is 1 through 16. So you have a 4-line heading when you're doing book assignments. Your name is the first line. What's up here on the board are the other 3 lines. It's always that easy. When is this assignment due? Tomorrow. It's always due tomorrow unless there's another note here that says something else. Well, there's no other note here, so this is due tomorrow. Okay? Be sure to use your notes and your book to help you out so that you know what you're doing. And you actually should be able to get a start on it. Anybody have questions?